In this video we have 4 questions. The first one is simplifying ratios. The second, question 15, is looking at best buy. We're comparing 2 buys. And then question 16 and 17 is converting between decimals and percentages. So 4 questions. Feel free to skip to the question you're interested in, which is indicated in red. Question 14, we're looking at simplifying ratios. So these 3 examples here are examples of ratios, and that's shown by these little double dots here, or columns I think they're called, aren't they, in English class. So let's look at what does actually a ratio mean, and I'll use an example. Let's look at this one, 6 into 30. That's like saying if you had a class of 36 students at school, and you had 6 boys and 30 girls. That'd be a pretty good class to be in. I'd be pretty keen on that class. So that would be a typical gender ratio. 6 boys, 30 girls. Now, when we say simplifying these ratios, it would be like when you're driving home by your parents and they say, what's the ratio between boys and girls in your class? Well, you wouldn't really want to say 6 to 30. You want to say a little bit simpler, like, I don't know, 1 boy for every 5 girls, or 1 boy for every 4 girls. Let's go and find out how to simplify it so we can say it in simplest form. Okay, so this is how I would do it. The first thing I do, it's very similar to simplifying fractions. So I'm going to go write it as a fraction, 6 over 30. Now let's go and simplify this fraction. Well, I know that 30 divided by 6 is 5. So we can just divide top and bottom by 5 here. So, by 6, 6, let's divide top and bottom by 6. So it's going to be 1 over 5. And we can now rewrite this as 1 to 5. So instead of saying that our boy to girl ratio in a class is 6 boys for every 30 girls, we can say 1 boy for every 5 girls. Let's go ahead and do the next one. So I'm going to write this as a fraction. 42 over 28. Well, let's go and simplify this. Let's look for... Okay, 7. 7 goes into both of these. 7 times 6 is 42. 7 times 4 is 28. Well, we're still not in simplest form. We can divide top and bottom by 2. Let's write it here. 6 divided by 2 is 3. 4 divided by 2. There we go. So now we're in simplest form. So we can simplify this ratio as 3 to 2. Now, this one here, this is a little bit tricky. The first step, as I said in a previous hint, always convert your improper fractions to normal fractions. So I'm going to go do that now. 2 times 1 is 2, plus 1 is 3. 3 times 3 is 9, plus 1 is 10. So now we have fractions that we like to see. Now I'm going to go and divide these fractions, similar to what I've done before. So 3 over... Actually, I won't write it. I'll save some space. Instead of writing this ratio sign, I'm just going to write a divide sign. And now I can flip the second fraction and change the sign to multiplication. There we go. I can now times the top, 9 over 20. Now, is this in simplest form? Well, yes it is. Yes, it is in simplest form. So now I can write this as 9, 20. This is a simplified ratio of this. And this is a technique that I use to solve ratios. It's quite good. I like it. There could be others, but so I convert it to normal fractions, and then divide, and then use the techniques that we showed in questions, I think 11 and 12, to then find our final simplified ratio. Question 15 is a worded question which brings in what we looked at with ratios and fractions, and it's quite a good question. It's quite lifelike, really. Let's say that we went shopping one weekend and we bought at say, Aldi, and we bought 700 grams of apples for $14. The next weekend we went to Woolworths and we got 1.5 kilograms of apples for $30.90. And our parents asked us, what was a better buy there? And what do they mean by what's the best buy? What they mean is, if you looked at the price of apples per kilo, which one was cheapest? So at the moment you've got 700 grams for $14 and you've got 1.5 kilograms for $30.9. So it's hard to compare this. We need to now bring the weight to the same, which universally is done as per kilo. So I'm going to show you how I'd go about doing this. For starters, I'm going to work in kilograms. So 700 grams, I'm going to write this instead as 0.7 kilogram. This is the same thing. So I like to write that as price over the weight. So I'm going to write that as 14 over 0.7. I'm working in kilograms. And the second one will be $30.90 over 1.5. Now I want to compare this as the cost per kilogram. So I want to convert both of these denominators into one on the bottom. That'll be per 1 kilogram. So how would I go about doing that? Well, just as an aside, if I have any number over a number, let's just say, I don't know, I'll choose 99 over 99, or let's say 0.1 over 0.1. If I have the same number over its same number, the answer is going to be 1. So that's a big hint here. Okay, so I know that for each of these fractions, I'm going to divide top and bottom by the denominator, because that will get my denominator as 1, which I want. So I'll divide this one by 1.5. I'll get this out of the way, not needed anymore. And I'll divide this by 1.5. And I'll bring my calculator in for this. So I'll put this over here. We know that it's going to be over 1, and this is going to be over 1. 14, probably should do this one in my head. 20. Yeah, I should have done that in my head. So this one here for the first one is $20 per kilo, price over weight. So at Aldi when I was shopping, the apples were $20 per kilo. Let's look at the other one. 30.9 divided by 1.5. 20. Oh, it's a close one. 20.6. So at Woolworths the week later, the price of apples was $20.60 per kilo. So, which is the best buy? Well, we always want to be on the cheaper option. So the option of $20 per kilo is cheaper than $20.60 per kilo. Pretty similar, I know, but to answer the question, I would say that the first one is the best buy. So it is $20 per kilogram. So again, the key for this is to convert it into a similar weight. We had 0.7 kilograms, we had 1.5 kilograms. We need to make it so you can compare, so convert both into per kilogram. And that's the key for question 15.
Okay, question 16. We are converting decimal numbers to percentage numbers. Now, this is pretty straightforward technique that I want to use here, and it's just a little bit of fraction work when you can times and divide by the same number. Now, the key to converting pretty much usually fractions or percentages into percentages is timesing and dividing by 100, and I'll show you how that works. So this number here, 0.34, if we were to times it by 100, or we could just move the decimal point 2 times, because 100 has 2 zeros, it'll be 34. But we can't just times a number by 100, because that's illegal. You have to divide by 100 as well if you want to keep it all balanced. So now we have 34 divided by 100, and now this is in fraction form, which that is actually a conversion just from decimal to fraction. But we know as a percentage, or this could be 34 out of 100 in a maths test, or if you were trying to shoot 100 hoops and you got 34 of them. So we know this step here to convert into a percentage is actually quite easy, because it's just 34%. So if you have a number over 100, or number divided by 100, we can go straight away and make this number as the percentage. Or you might see in a textbook they get this number and just times by 100 to convert into a percentage. this is the same step, but we're just using our head to get this number here. Alright, we'll do the same step here. Times it by 100. I'll move the decimal place 2 times 40. Because we times it by 100, we have to divide by 100. Alright. Again, 40 out of 100 in a... Well, it wouldn't be a maths test because we're all good at maths. So maybe let's say it's an English test. 40 out of 100. We can just make this number, because it's over 100, our percentage. Or times by 100, like the textbook might say, but I like to see this step a little bit easier. Now, this one could be a little bit trickier, but we'll just see how we go. We times by 100, so move the decimal point 2 times. 132. And now we have to divide by 100. And you could write as 132%. I think that's right. But this would be a maths test, getting 132% in your maths test, because we're all good mathematicians here, but it's as simple as that step. So there are 3 answers. Now, question 17, we're converting percentages to decimals. Now, question 16, the one before this, was the exact opposite. We're converting decimals to percentages. So if you wanted to have a little background, go to question 16, and what we're actually doing here is the exact opposite. Right? So let's use the question 16 techniques to convert these percentages into decimals. So what we were doing in question 16, and we'll go on the other way, that last step where we had either a fraction and we wanted, or it was a fraction and we wanted to convert it into decimal, we had a fraction and wanted to convert it into percentage, we just times it by 100. So if we want to do the opposite step here, we already have percentage, and we want to convert it back to a fraction or a decimal, right? Let's just divide it by 100. So 67% turns into 67 over 100. Now this is a fraction, right? So not quite yet our decimal answer, but again, we'll use the reverse step of question 16. At the moment, we have 67 divided by 100, or 67 out of 100 in a test. Now this can be written as 0.67, because if we divide by 100, that's like saying we have, let's put some zeros here. Oh, not there, sorry. If we divide by 100, we move the decimal place 2 that way. So we get 0.67. Right? So this is our decimal answer now for 67%. Alright, here, let's divide by 100 again. 250 over 100. So now we've converted our percentage into fraction form. Right? So now we have our decimal spot here. Let's put it 2 that way. So our answer in decimal form is 2.5. Right, just with the decimal conversion. Now, we have an improper fraction percentage. It's a bit of a ugly looking one. So I'm going to do a few different steps here. The first step I'm going to do is just convert this to a normal fraction percentage. Okay, now that might be a bit confusing, but at the moment it's just an improper one. Now remember the rule here, we go the big number times it by the denominator, or the bottom number. So 4 times 4 is 16, and we have to add the top number, so 19. And we divide it by what was already the denominator, 4. Alright, so we've got now 19 over 4%, and we want to convert it into fraction, no percentage anymore. We have to divide it by 100, so we can go 19 divided by 4. We want to divide it by 100, but if we want to divide by 100, at the moment this could be a little bit tricky. We don't want to use a calculator just yet. How can we maybe make this a little bit easier using techniques in earlier questions? Well, what we could do, if we want to divide it by 100, we can also times it by 1 over 100. And that one, if we had divided by 100 over 1, we can times it by 1 over 100. So it's that flip thing. And we did a few questions on that earlier, if you want to go back. So now we can get times the top and times the bottom, because multiplying fractions are easy. We have 19 over 400. Okay, now we're nearly there, but it's a little bit not quite very neat, because we want it as a decimal. Now how did we get it as a decimal before? Well, we got it over 100. Right? Once it's 100, then we can just move the decimal point. So if we want to get this bottom line 100, right, we need to, can we see that on the side of the screen? We need to divide it by 4. Right? If we divide that by 4, we need to divide the top by 4. Okay? Now, this will get the bottom line to be 100 because 400 divided by 4, but the top line isn't going to be, this time, a perfect number, right? Because 19 divided by 4 isn't going to be a number, because 20 divided by 4 is 5, right? And 16 divided by 4 is 4. So it's going to be in between 4 and 5. So probably maybe use a calculator here, or we could do it at hand, but just for sakes here, I'm just going to put it on my calculator. Okay, we're going to go 19 divided by 4. We have 4.75. Right. Now that we have this, we can convert this into a decimal just by moving the decimal sign twice. So after all that, we have 0.0475. Right. Now I used my calculator there, but you probably could have worked out this 19 over 4 using earlier division techniques, but once we got it over 100, we could find our decimal answer.